Hello everyone, this is Gurmeet from S-Connect UK. Today I'm going to talk about the latest technology, LoRaWAN. It is a technology that's transforming the way we connect devices over long distances. If you're into IoT or curious about the future of wireless communication, then you're in the right place. So let's dive right in. So, what is LoRaWAN? LoRaWAN stands for Long Range Wide Area Network. It is a network protocol built on top of the LoRa physical layer. Now, LoRa is actually designed for long-range communications while consuming minimal power. It operates over unlicensed radio frequency bands. As you can see in the map here, we have different frequency all around the world. For example, we have 868 MHz frequency used in the EMEA region. Now, let's see how the LoRaWAN architecture looks like. So, firstly, we have the LoRaWAN end devices or the sensors which collect this data and send it to the nearest LoRaWAN gateway. So once you have a gateway installed on your premises, you can connect up to 2000 LoRaWAN sensors to this gateway. The communication between the devices and the gateway is LoRaWAN. They talk LoRaWAN to each other. Gateways forward this data to a lower network server over Ethernet or cellular, whichever backhaul connection you have to the internet. This network server can be public or private. We will discuss this in detail in our later video. In this case, let's say we have a public network server like the Things Network, ChirpStack or LoRaWAN and etc. LNS is the central manager of this whole architecture. It manages the communication and configuration of LoRaWAN devices within the network. It handles tasks such as device registration, activation, and authentication. It routes data packets received from LoRaWAN devices to the appropriate application servers. It also handles other major tasks such as security, QoS, scalability, and monitoring. Application servers at the end perform data processing, analysis, and visualization. It turns this raw data into useful data format and forms meaningful information. It provides user interfaces, dashboards, or APIs for administrators, developers, or end users to interact with the system, visualize data, configure settings, and access relevant information. So all the data is secure and end-to-end encrypted with AES. We'll all see this in action in our next upcoming video, where I'll be performing a live demo using a LoRaWAN sensor, a gateway connected to the LoRa network server, which is further connected via webhook to an application server. So we will be able to see a nice dashboard with graphs and charts of the data collected from the end node. Now, let's look at some of its advantages that makes it stand against the other technologies. As we are aware now, LoRaWAN operates on unlicensed bands, so it is a global standard with an open approach and a strong ecosystem. It has end-to-end security with AES encryption with the combination of joint server keys, application keys, and etc. It supports bidirectional communication, enabling not only the transmission of data from sensors to the network, but also commands and configurations from the network to the devices. It supports long-range communication, so we have 15 km range of radius in rural areas and a 2 km radius in a dense urban environment. It has got maximum lifetime of 10 to 15 years of battery life. It can depend on the type of LoRaWAN sensor we have, so we'll talk further about the class A, B, and C LoRaWAN sensors in the upcoming video. Cost efficiency is one of the major advantages over other technologies. If we compare it to an application where we have a number of sensors with cellular connection, they have a fixed monthly cost for the data for each sensor. Whereas in the LoRaWAN, we have a single gateway to which up to 2000 LoRaWAN devices can be connected, and the data is pushed forward to a LoRa network server. Overall, there is a significant amount of reduction in the implementation and low service cost too. In the upcoming series of the LoRaWAN videos, we'll be discussing about the various applications where LoRaWAN can be adopted. For example, in a smart building settings, we can have environmental sensors, people counting sensors, occupancy sensors, and many more. I hope you liked this introduction video. Please give us a follow if you like such content. If you have any queries, please send us an email and one of our team members will be in touch with you. Thank you and have a nice day.